Okay, the last lesson of chapter 10, the second day on hyperbolas. Not surprisingly, we're going to deal with a scenario where we're going to have to complete the square. Our hyperbola is not in vertex or centered form. And that's also called, just getting your x terms together, negative x squared minus a 2x. Here we'll have a plus 4y squared minus a 16y. I've got this plus 11, and I could just subtract an 11 to make this look a little bit easier. I should always factor out my leading coefficient. I'm going to factor out a negative 1. And factoring is really dividing. So that's just going to change the sign for both of those terms there. For my second grouping, I'm going to factor out a 4. And then we'll have 4 outside. We'll have y squared minus a 4y. And then over here is negative 11. What you're going to have to do is complete the square. We've been doing this all unit long. Let's do that. Take half of your linear term, half of that 2, and half of 2 is 1. I'm going to put a little star there. We're not done seeing that. And square that term. And 1 squared, of course, is just a 1. You're going to add a 1 inside the parenthesis. But did I really add a 1 to the left-hand side? No. No? You see, what was factored out in front is still there. Look, if you redistribute that negative 1, which you're more than welcome to do, you'd see that the new term that would remain there would be a minus 1. And the golden rule of algebra is what you do to one side, you must do to the other. Now you come over to the second square that you need to complete. You can see, well, I've got that minus 4y there. I'm going to have to take half of that negative 4. Half of negative 4 is negative 2. I'm going to put a star there. And I'm going to square the negative 2, and I'm going to get a 4. And I could say, well, I'm going to do a plus 4 right here. But I really didn't add a 4 to that left-hand side. I really am adding a 16. And what you're going to see then is this right-hand side is negative 11 minus 1, which is negative 12. Negative 12 plus 16 is going to get you a 4. And then over here I've got my negative 1, but you might remember I said put a star by what you took half of. It's a friendly reminder to say, you know what? That's going to be your perfect squared term, right? Always. This is a factoring problem by design. We're rigging it up to factor. And then you could say, well, I've got my plus 4 over here. This thing factors too. What did I take half of? I got negative 2. Rather than trying to factor it out, this is a huge time saver, right? Yeah. So now what? Well, tell you what, I'm going to slide this over a little bit, and I'm going to rewrite this problem. I'm going to have my positive term coming first, 4y minus 2 quantity squared. Then I have my minus 1, x plus 1 squared, but that's all equal to a 4. And it's beginning to look a lot nicer, right? Yeah. But I don't want to see a 4 on the constant right-hand side. I'm going to... Can you just move the x to the right side? No. You want to always have a 1 on the right-hand side, right? You want to have your x squared and y squared terms together. They're going to be joined by subtraction. But the right-hand side must have a 1. So I'm going to divide by that 4, and I'll have a 1 right here. Here these 4's cancel, and you'll have a y minus 2 quantity squared all over. Really, that's a 1 squared if you think about it. And this is your x plus 1 squared all over a 4. Really, that's a 2 squared down below. And, right now you can say, well, I know what my center is. What's the center of my hyperbola? Negative 1, 2. And by the way, would my hyperbola be opening in the y direction or in the x direction? It'd be in the y direction because y is positive. Whatever is positive. So what we're getting at is this. You could real quickly say, well, here's -1 comma 2, right? Here's your center, but you'd be going up one step and down one step. This is where you're going to get your vertices, right? You go up one and you go down one. Now, a graph can help. I know they didn't ask for that, but if you're going up one step, guess what one of your vertices would be? -1 comma 3. And what's your other one? -1 comma 1, right? And that here are your two vertices. Now, of course, you could also say, well, if my b squared was 4, that means my b would be 2. I know they're not asking us to graph, but it never hurts to just review how you would go ahead and make a graph, and you could see your diagonals getting formed, right? And that's really nice. And then you could say, well, yeah, I've got my vertices here, and wow, that would be a nice graph. Now, there are two additional pieces of information that we're going to be asking you for. One would be the asymptotes, yes. The other would be the foci, right? Now, the foci, if you think about it, we know that c squared is equal to a squared plus b squared. And you already know that your a squared is really a 1, right? And your b squared is right here. That's going to be a 4. And 1 plus 4 is 5. And, you can take your square root. That's your focal distance from the center, right? It's from the center. So you're saying from the center, rise up radical 5 steps, go down radical 5 steps. You don't even need a picture to see that. Here we could use a real quick shortcut. When I'm rising up and falling down, I'm affecting what coordinate, x or y? The y. So guess what? I'll be at -1 comma, and I had a 2 for my center, but we're going to say plus or minus radical 5, right? Is that making sense? Okay, but now we have to talk about our asymptotes. And for asymptotes, we said, look, if you don't have your situation where your center is at the origin and you can use y equals mx plus b, you have point slope. You're going through the center, guys. Your center is a point in common for both of those. That's your x naught and y naught. So I could say I'll have y minus 2, and over here I'll have x minus -1. What so many kids will point out is it's like your centered form of your hyperbola. You get those parentheses showing up again. But your slope is always change in y over change in x. How much am I going up and how much am I going over? 1 over 2. It's plus or minus rise over run. It's going to be your change in your y direction over your change in your x direction. We doing okay with that? All right. Last problem. Write the equation of the hyperbola with foci at plus or minus 10, 0, and asymptotes at plus or minus 4/3 x. Please watch out. Please watch out. This is where we have to be exceptionally careful. You could give yourself a little bit of a sketch. You could say, look, your foci, and you don't even have to have it graphed perfectly, to scale. You could say my foci are over here, and, if I were to connect my foci with a segment, I have a horizontal segment. And using symmetry, you could pretty much see that your center would be at 0, 0. And that would mean that your C would be 10. And before too long, kids will quickly and happily, correctly say, wow, I know if I've got this kind of a situation, I know that the general form, and this is going back from yesterday, would look like this. If my center's at 0, 0, and if I know that I'm opening my hyperbola up in an x direction, I know that my x squared term must be positive. And then here's where we can get into a lot of trouble. Here's where we have to be real careful, guys. A lot of times kids will say, oh, this is so neat. Now I know what my A and my B are. You can see that, we'd rise up over B. Kids would say, your slope, as you'd build a little box here, for wherever your vertices are, kids will say, hey, I get the idea that it's going to be B over A, and B over A is 4 over 3. So B is 4 and A is 3. You have to be careful that the slope may have been reduced. Do you see what we're getting at? That's the big surprise. Excellent test question. Excellent test question for any pre-calculus test, right? Never assume that the slope that you're given has to give you the exact B over A. It does give you B over A in a reduced form. And you could say, oh my gosh, so B over A, you could say is 4 over 3 simplified. But then you think, how in the world can we know what B over A is if we weren't reducing it? There's a reason why they gave you the foci. C squared is A squared plus B squared. And we could say 10 squareds equal to A squared plus B squared. So I have 100 is equal to A squared plus B squared. And you could say, well, oh my gosh, what can I do here? Well, you could say that B, if you just multiplied both sides by A, B would be 4/3 A, and I can plug it in to find out what A and B really are equal to. Because chances are your slope has been reduced. So let's think about this. I'll have 100 equals A squared plus, here's 4/3 A quantity squared. So let's see, I'll have my A squared plus 16 over 9 A squared. And getting a common denominator, making this 9/9, 16 plus 9 is 25. Look at that. Wow. So this is 25/9 A squared. And wow, then what? Well, my word, we could multiply by 9 and divide by 25. Now get a load of this. Look what I'm about to do. I'm not even going to officially do all of the arithmetic here. This can look so strange at first. I'm going to leave it as just 9 times 100 all over 25. You think, why in the world are you going to do that? Because I need to take a square root. And guess what A is going to be? What's the square root of 9? 3. What's the square root of 100? 10. What's the square root of 25? What's 10 divided by 5? 2. 2 times 3 is 6. Oh, A is 6. Wow, slick. Isn't that nice? So then you'd say, well, wait a minute. What about B? B was equal to 4/3 A. Well, B is 4/3 times 6. 3 goes into 6 twice. 2 times 4 is 8. Hey, look at that. We didn't have a reduced form. B was 8. A was 6. So we're going to come back up here. We've got x squared over A squared minus y squared over B squared was equal to 1. So it's x squared over 6 squared minus y squared over 8 squared. X squared over 36 minus y squared over 64. Guys, that is your answer. And hopefully that is going to make sense. Be careful when they give you asymptotes. Your slope might have been reduced. You might have to set up a system of equations like we just did. And if you confirm it, if you think about it, if B was 8, if A was 6, 8 over 6 is 4/3, isn't it? Okay? So that's our lesson.